Intermediate Algebra for Statistics, Introduction to Functions. Lesson objectives: define a relation, domain, range, and a function. Determine if a relation is a function. Lesson objective: definition. A relation is a set of ordered pairs. The domain of a relation is the set of all values of the independent variable, and the range of the relation is the set of all values of the dependent variable. We can think of a relation as a machine in which values of x are the inputs and values of y are the outputs. In general, each member of the domain is an input and each member of the range is an output. So here's the visual. Our independent variable x are inputs. In this example, our domain is 3, 4, and 5. This is the relation. We put in 3 and we get an output of 2. When we put in 4, we get an output of 1. And when we put in 5, we get an output of 3 and 4. These are our outputs, and the values 1, 2, 3, and 4 would be our members of our range. Here's an example of a relation described by a table, and here's an example of a relation described by a graph. This is a poster from the movie Men in Black. Of course, this involves Mr. Jones and Mr. Smith. So we're going to look at a relation involving last names. So these are the top U.S. last names. Smith has about a little bit more than 1% of all last names in the U.S. Johnson is next. Williams. We have Brown, which is 0.621%, and Jones, which is 0.621%. So this is an example of a relation. These are the inputs and these are the outputs. Example 1. Find the domain and range of the relation of our last example. So the domain would be Smith, Johnson, Williams, Brown, and Jones. And usually we put fancy parentheses when we're talking about domain. Sometimes this is called set notation. So we have fancy parentheses and then you list the members of the domain. So the range would be fancy parentheses 1.006%, 0.810%, 0.699%, and 0.621%. We don't have to write this twice. Lesson objective. Definition. A function is a relation in which each input leads to exactly one output. So here we can think of this as a function machine. You put in an x, the function spits out what is called an f of x, an output. We'll talk more about f of x later. Example 2. State the domain and range of the following relation. Is it a function? So the domain is -2, -1, 0, 1, and 2. The range is 1, 2, and 5. And yes, this is a function. For every x, there is one and only one y. Example 3. Consider the relationship of the students in a class and the scores on their first test. So is this relationship a function? And the answer is yes, this is a function. Two students can have the same score for the first test. This happens all the time. What doesn't work is if we have one student that has two different scores for a test. The x value, being the student, has to correspond to one score on a test. You can't have a student having two different test scores. So we're going to look at some examples of functions. Functions are used to describe a cause and effect relationship between two variables. There are several ways to express this relationship. Here's a business example. The quantity sold is related to the price charged. Quantity sold depends upon price charged. The quantity sold varies with the price charged. The quantity sold is a function of the price charged. The idea is the same. There is a relationship between price and quantity. So when we see these words, is related to, depends upon, varies with, is a function of, this is all indicating that there is a relationship between these two variables that is a function. Price charged would be the input, quantity sold would be the output. So when you see a statement that says a variable is a function of another variable, whatever is expressed last, that is your independent variable. Now here is a graph, the price charged and the quantity demanded, and we can see as the price goes up, the quantity demanded goes down. If we're given a graph, the horizontal axis indicates the independent variable and the vertical axis indicates the dependent variable. Here's some more examples of functions. A revenue function shows how the revenue received by a company for a product varies as a function of the quantity sold. A cost function describes the cost incurred by a firm in manufacturing a product as a function of the quantity produced. And a sales response function is used in marketing to indicate the sales revenue that a firm receives from the sale of a product as a function of the expense in advertising. In a hospital, the amount of medication given to a patient is a function of the patient's weight. In sports, a progress curve shows how to describe an athlete's performance in an event as a function of the time spent in training. Deciding whether an equation describes a function. Is the equation y equals x plus 2 a function? Find the domain and range of this relation. So if we consider some input-output pairs of the table on the next slide, we put in 0, we get back 2. Put in 1 for x, and we get a 3. Put in 2, and we get a 4. So this would be a function. For every x, that will be 1 and only 1 y. If you recall, this is a linear equation. And for every x, there is only one y value on this graph. Now, if we look at the domain and range, we can see that any x will have a point on this graph. And if we look at the y values, the range, that is also true, that any value will eventually have a spot on this graph. So if you have a straight line that is not vertical, the domain and the range will always be what is called all real numbers. So all real numbers means that any number can work. Example 5, is the relation y equals plus or minus x a function? Well, let's do an input. If x is 1, we substitute it in and we see that y is plus or minus 1. An input of 1 leads to two outputs, a positive one and a negative one. Therefore, the relation y equals plus or minus x is not a function. Example 6. Is the relation y squared equals x a function? If we consider the input x equals 4, we have y squared equals 4, and this is an equation where we want to know what values when we square give us 4, where there's actually 2. Y can be a negative 2 because a negative 2 squared gives me 4, but also a positive 2. 2 squared is 4. So this is not a function because we have an input that leads to two outputs. So this is not a function. Example 7. is the relation described in the table a function? So we have 0 goes to 2, we have 1 goes to 3, 1 goes to 5, 2 goes to 7, 3 goes to 10. When x equals 1, we have two outputs, y equal 3 and y equal 5. This is not a function. Example 8. Is t a function of r, y or y not? Is r a function of t, y or y not? So in this first question, is t a function of r? R is the input variable. T is the output. So we go to the R and we have to check and make sure that every R is different. That for every R we have one and only one T. And we do. So this is yes. And Y, for every R, there is one and only one value of t. Now the next question says, is r a function of t? T now is the input and r is the output. So we have a problem. We have a 7 going to a 40, but then we have a 7 going to a 50. So this is not a function, and the reason why is for the input 7 we have two outputs, and those outputs are 40 and 50. Vertical line test. A relation is a function if and only if every vertical line intersects the graph of the relation at no more than one point. We call this requirement the vertical line test. So the idea behind this is if we're given a graph, we draw a vertical line. That vertical line can only intersect the graph at no more than one spot. Let's look at some examples. So we can see the first graph is a function because at each x it is only intersecting the graph in one spot. If we look at the next graph, this is not a function because for this one x we're having multiple values of y, so it fails the vertical line test. It is intersecting the graph in more than one spot. Example 9. Determine whether the graph represents a function. Number 1, we can see that this graph fails the vertical line test because it is intersecting in two places. So when x is 3 we have a y value, and when x is 3 we have a different y value. Number 2, this is a function. Any vertical line that we draw will only intersect this graph in one spot. So this is a function. Are these functions? Take a second and look at the graph. This is a function. This is a function. This is not a function. This is a function. Not a function. A function. Thanks for watching.